Welcome again to integration of exponential and tanx. We want to see how to integrate this. Now, for us to integrate, we need to derive shortcut we will use whenever they ask us to integrate it. We now say equate this to exponential ax tan bx dx. That is, a is 2, b is 4. When we are able to integrate this, then you will now use it as a shortcut. Call this your I and call this your D. Now see what we mean. D, I. You use tabular method to integrate. We now say D is what? Tan bx. I is what? Exponential ax. Now, this means differentiate this. It will be giving you b sec square dx. Integrate this 1 over a exponential ax. You come again. Differentiate this. If you have to differentiate b sec square dx, see what it will be giving you. It will be giving you, this means b sec dx sec dx. So call this your u and call this your v. Say the u is equal to differentiate bx times b sec differentiate bx times b, then differentiate sec bx times bx. Then differentiate v, that will be b sec bx times bx. Then this will be giving you b square sec square bx, b square sec bx times bx. Now you apply product rule. Product rule means put down the first b sec bx, put the differentiation of v, put down the first, put this, the differentiation of v, that will be b sec bx times x times bx, plus put down the second, which is sec bx, put the differentiation of u, b sec, differentiation of u is b square sec bx times bx. Okay, this will be giving you b square sec square bx times bx plus b square sec square bx times bx. Then when you add the two, it will be because everything you have here are the same, so it will be giving 2b square sec square dx times dx. Okay? Then I will say differentiation of this will be giving me 2b square sec square dx times dx. Then integrate this 1 over a square exponential ax. Now, because what we have is exponential tan bs, we have tan bs exponential in this line. What you do is that you put arrow this way and put plus, minus, plus. This plus, minus, plus, they are constant. Plus, minus, plus, they are constant. This means plus tan bx tan this. So see what we do. We call everything here exponential I. We now say exponential I equals to this times this. That will be giving me exponential ax times what? Bx all over a. Then this times this minus b exponential ax sec square bx all over a squared. Okay? Then what you now do is that multiply these two, you now say plus 2b squared sec squared dx tan dx exponential ax all over a squared. Remember, totality of this is your I from here. Okay? Then carry it to the other side. You say integration I equals to, I will now say integration I minus 2b squared sec squared dx, then I all over a squared. Okay? Equals to exponential ax tan bx all over a minus b exponential ax sec square bx all over a squared. Okay? Now when you factorize out, you'll be having integration I is what they have in common. Remember I said when you multiply these two and you write, you put integration I, because this did not give you 0. The differentiation aspect did not give you 0 at a point. That is why you are putting integration I as a symbol. Then factorizing bracket 1 minus 2b squared sec squared dx all over a squared equals to exponential ax tan bx all over a minus b exponential ax sec squared bx all over a squared. Okay, then what you have here, when you look for LCM, here will be giving you a square minus 2b square sec square dx, then bracket integration I equals to, I will now have this again, exponential ax tan bx all over a minus b exponential ax sec square bx all over a squared. Then carry this to the other side. If I do so, I will be having integration I as subject of formula equal to, then this will be exponential ax tan exponential ax tan bx all over a divided by a square minus 2b square sec square dx all over a squared. Then what I will now do, minus b exponential ax sec square bx all over a squared divided by a square minus 2b square sec square bx all over a squared. Okay? Then you remember that when you remove division and replace it with times, you will invert the second fraction. You say integration I equals to, I write exponential ax tan bx all over a times a squared all over a squared minus 2b squared sec squared dx. Then I will now say minus, I will now write again b exponential ax sec square bx all over a squared then times a squared all over a squared minus 2b squared sec squared bx. Then what you notice is that this will cancel this and this will cancel this to give you a. So we'll be having finally that integration. What is my I? Exponential ax tan bx dx equals to, then what do I have here? What do I have in common in the two? I will say I have exponential ax all over a square minus 2b square sec square dx. Then what will remain? I will say a times is a tan bx minus what remain here? B sec square dx. So I will say this is the integration formula I'm going to use. I included plus c because this integration symbol does not have upper and lower limit. Now I want to solve this question. Integrate exponential 2x tan 4x dx. I will say my a, comparing it with this, my a equal to 2, my b equal to 4. I put in the formula, I say integration exponential 2x tan 4x dx equals to, what is my a? 2x all over 4, 2 square is 4 minus 2 times 4 square is 16 times 2 32 sec square. What is my b? 4x. Then bracket I will now say what is my a? 2 tan 4x minus 4 sec square. What is my b? 4x. Then after writing this, I will say plus c. So exponential 2x bracket